This is the video for section 8.2 notes, slides 17 and 18. All right, so it says find the volume of the solid generated when the region bounded by x equals root y, x equals 0, and y equals 4 is revolved about x equals 3. All right, so I have this graph here. Now, x equals root y. What is that? Well, remember, x equals root y. If I square both sides, that's like y equals x squared, right? So, okay, we have this parabola here. But remember, if I have x equals root y, that is the positive square root of y. So it actually does not include any of that part. So it's really just this kind of right side of that parabola. So important to make sure we understand that. All right, x equals 0, remember, vertical line, the y-axis. All right, y equals 4, horizontal line right there. Okay, and now is revolved about x equals 3. So x equals 3 is right here, right? So I'm going to put that there, that circle with the arrow to make sure we understand which thing we're revolving around. All right, so we are talking about this region right here. Remember, in quadrant 1, not the part over here to the left of the y-axis. All right, so now what we want to do is we want to figure out whether we should use a dy or a dx, okay? Now, we want to use a dy. Okay, so the question is why a dy? All right, so let me use another color here just to like highlight this. All right, so why do we want to use a dy? Well, remember, a dy is perpendicular to the axis of rotation. So the axis of rotation is a vertical line, so we need to use a horizontal rectangle, which is a dy. All right, so that means I want my equation in x equals, which it is, right? That's what we were given. All right, and now the axis of rotation is not a boundary of the region, and so that means we are going to be using the washer method, right? So the washer method, the setup, remember, is pi times the definite integral of big parentheses and then a dy, and then little parentheses squared minus little parentheses squared, right? So remember, this is pi times big R squared minus little r squared, and then with respect to y. All right, so big R. Remember, big R represents the distance that the furthest boundary is from the axis of rotation. So now the axis of rotation is y equals 3. So the furthest boundary is, sorry, not y equals 3, x equals 3. The furthest boundary is x equals 0. So how far is 3 from 0? Well, we're going to say 3 minus 0, right? I take the right-hand value, which is 3, minus the left-hand value, which is 0. So that's big R. Little r now is the distance that the nearer boundary of the region is to the axis of rotation. So how far is this root y from 3? Well, we're going to take 3 minus root y, all right? And that is how we evaluate that. All right, so now I'm integrating from what to what? Well, from the lowest y value, which is 0, to the highest y value, which is 4. So the integral from 0 to 4, right, of 3 squared minus the quantity 3 minus root y squared. All right, so now I'm going to simplify. All right, so I have integral from 0 to 4. 3 squared, of course, 9, minus, now I have this, which is 3 minus root y squared. So remember, that means 3 minus root y times itself, so 3 minus root y. So if I multiply, I get 9 minus, then I get a minus 3 root y and another minus 3 root y, so I have a minus 6 root y. And then I have a minus root y times a minus root y, so that's a positive root y, which is just y. All right, and so now I have that here, right? So 9 minus 6 root y plus y, right? And so now I distribute the negative to simplify further. And so I have pi times integral from 0 to 4 of 9 minus 9, of course, that's 0. Then distribute there, so I get positive 6 root y, and then minus y, and then dy. So now this becomes a relatively easy integral to carry out. So I have pi times, all right, integral of 6 root y. So that's going to be 6 times. Now remember, y is really y to the 1/2, so it becomes y to the 3/2 divided by 3/2. All right, minus y squared over 2, and then I'm going to evaluate from 0 to 4. Now, keep in mind, you got this pi that does need to be multiplied by everything. All right, so now I've got the pi here, and then I'm going to use some parentheses. All right, so 6, and then I divided by 3/2. That's like 6 times 2/3, which is actually just 4, right? So now I have 4 times 4 to the 3/2 minus minus this y squared over 2, right? So it's going to be 4 squared over 2, right? Okay, so now I have that. That's the first part. Then I have minus, and then I've got 4 times 0 to the 3 halves minus 0 squared over 2. And then all of that has the pi multiplied on the outside. All right, so now I have pi times. All right, 4 times 4 to the 3 halves. Remember, 4 to the 3 halves means the square root of 4 cubed. So I take the root first, which is 2. Square root of 4 is 2. 2 cubed is 8. So 4 times 8 is 32. Minus 4 squared 16 divided by 2 is 8, right? Then I have minus, well, 4 times 0 to 3 halves is 0 minus 0 squared. So that's all just 0. So 32 minus 8 times pi. So I have 24 pi, right? So that would be the area, sorry, not area, volume of the solid generated when the entire region is revolved about the line x equals 3. All right, so that is slide 17. All right, slide 18. Now, okay, I'm taking the same region, x equals root y, x equals 0, y equals 4. So remember, not this part of the parabola, right? So just this region again, right? And now I'm revolving around y equals -2. So now y equals -2 is down here. Y equals -2 is a horizontal line. So now that means I need to use a vertical rectangle. So now I need to use a dx rectangle. So what does that mean? Well, that means now that instead of x equals root y, I need y equals x squared, okay? Now, this is still a washer method problem. So I'm going to start with my pi times the integral, and then I have my big parentheses with respect to x now, dx. All right, and then I have big R squared minus little r squared, right? So big R, little r. All right, now in this case, we're using a dx, right? And so now I'm looking at the further boundary from the axis of rotation. Remember, the upper part of the dx is further from the axis of rotation than the lower part, right? So now how far is 4 from -2? Well, it's 4 minus -2, right? Or 6, right? Obviously, 4 is 6 units from -2, right? But that's how we always do it. Take the upper thing minus the lower thing, or the right-hand thing minus the left-hand thing, minus little r. Now, little r, we take the nearer boundary, which is the parabola. Now, the parabola was x equals root y, but now it's y equals x squared. And so I'm going to take x squared minus -2, right, in order to find the distance there, okay? And then we're integrating now, remember with the dx, we're integrating from left to right. So we're integrating from furthest left, which is 0, to furthest right. Now, where do these things meet? Well, it's when y is 4, so square root of 4 is 2. So this point is 2 comma 4. So we're integrating with respect to x, so we're integrating from 0 to 2. All right, so now I'm going to simplify a little bit. I have pi times integral from 0 to 2 of 4 minus -2. That's 6 squared is 36. And then minus, now I have x squared plus 4 quantity squared, right? So now we have all of this. So now we're going to simplify further in order to actually integrate. So pi times the integral from 0 to 2 of, all right, so remember x squared plus 4, that really means x squared plus 4 times itself, x squared plus 4. All right, and so x to the 4th plus 8x squared plus 16, right? And so now I have 36 minus that, right? So 36 minus 16 gives us 20, right? And then I have a minus x to the 4th and then a minus 8x squared. And then we're going to integrate all with respect to x. So all relatively easy to integrate. So integral of 20 would be 20x, right? Keep in mind, we've got the pi in front, right? That needs to be multiplied by everything. All right. And then we've got minus, this would be x to the 5th over 5, and then minus 8x cubed over 3, and then evaluate that from 0 to 2. All right. So now we've got the pi in front, okay? And then I've got 20 times 2 minus 2 to the 5th over 5, all right, minus 8 times 2 cubed over 3, right? So all of that minus 20 times 0 minus 0 to the 5th over 5 minus 8 times 0 cubed over 3, okay? Now, the second part, well, 20 times 0 minus 0 to the 5th, right? That's all just 0, okay? So now we really just have the first part. All right, so I have pi times 20 times 2 is 40, minus 2 to the fifth is 32 fifths, minus 8 times 2 cubed, right? 2 cubed is 8, so this would be 64 thirds, right? And so now I need a common denominator of 15. So I'm going to multiply the 40 by 15 over 15, the 32 by 3 over 3, and the 64 by 5 over 5. All right, so 40 times 15. So 40 times 15, 40 times 10, 400 times. All right, so 600, right? So 600 fifteenths minus 32 times 3, 32 times 3 is 96 fifteenths minus 64 times 5, 320. All right, over 15. So now I have all of that times pi. So 600 minus 96 minus 320 gives me 184 fifteenths pi, right? And so that would be the volume of this solid generator when this region is revolved around y equals -2. All right, so that is slide number 18.